Hello everyone, in this video I'll be explaining you the problem maximum sum of three numbers. So it was asked in lead code biweekly contest 172. So let's read out the problem. You are given an integer array nums. Okay, your task is to choose exactly three integers from nums such that the sum is divisible by 3. Okay, so return the maximum possible sum of such a triplet. If no such triplet exists, return 0. Got it. So yeah, let's see. We have 4 2 3 1. We have 4 2 3 1. So this is the array. In the question what they ask is, so we are given nums of length n, and we need to choose exactly three elements. We need to choose exactly three elements in such a way that uh, let's say you have chosen the indices I, j and k of the elements. So now you have to make their sum. So whatever the sum is there, it should be divisible by 3. So this modulo has to be equal to 0. And it may happen that you will find more than one pairs. So you will have to return the yeah, we'll have to return the sum which is maximum. So maximum sum you will have to return. Sum is basically this thing. Okay. And it may happen that we don't find any such three pairs. In that case your answer would be 0. So this is the problem statement given. And let's try to solve it. Yes, we'll have to return this sum. So now so if you try to think of in a brute force way, so this will take order of n cube solution, but your n is 10 power 5 and n cube is like 10 power 15, which is way greater than 10 power 8. So this solution is going to be TLE. So we shouldn't be thinking in a brute force way, but we should be exploring the properties of modulo. So in this problem, if you explore the properties of modulo, and if you would have if you would have keenly observed it, you would have solved it easily. So first let's try to say we will take these three. So its sum is 7 plus 3 is 10. Modulo 3 if you do it is 1, so it is not equals to 0. So this sum is not, this pair is not valid. We'll take 4 2 and then 1. We have taken 4 2 3. We'll take 4 2 and 1. 7 8. 8 modulo 3 if you do this is 2, which is not equals to 0. Now we'll take 4 3 and 1. 4 3 and 1 will take, and its sum is 8 again. It is not valid. Now we'll take 2 3 and 1. So when you take 2 3 and 1, its sum is 6 modulo 3 if you do it is 0, and it is equals to 0. I think let me see. 4 2 and 3. I think I missed here somewhere. 4 okay, so this 2 3 1 is also one valid pair. Its sum is 6, and 4 2 3 if you're taking, so 4 plus 2 is 6 plus 3 is 9. Okay, sum is 9, modulo 3 if you do again it is 0. So among 6 and 9, 9 is maximum. So we need to find all the pairs and check whichever is the maximum. So when you do it brute force, it is going to take order of n cube. So this is not going to solve. So one thing we need to check is that okay, whatever three elements we are choosing, right? So the three elements, whatever you are choosing, let's say the three elements, so it's when you modulo with 3, your remainder is going to be 0 1 2. In the same way it is going to be 0 1 2. right? Let's say you're taking 4. If you modulo with 3, it is going to be 1. Our answer is, let's say here, our answer is 2, 4 to 3, right? So when you modulo 4, you're getting 1. When you modulo 2 with 3, you're getting 2, and you are getting 0. So see, 3 elements we have chosen, and when you modulo, you're getting this thing. Modulo with 2, you're getting this. Modulo with 3, modulo with 3 only, you're getting this. So if you sum its modulo, the elements modulo, it is going to be 1 plus 2 is 3 plus 0 is 3. So 3 you have got, again modulo with 3, it is going to be 0. So the thing is here, you need to find elements whose modulo is also divisible by 3. See, in mathematics you can write ABC modulo 3, which is equivalent to A modulo 3 plus B modulo 3 plus C modulo 3 whole modulo 3. You can write it this way, right? So the same thing I'm doing. I'm choosing the element and taking its modulo. Again, second element choosing, doing its modulo. Third element choosing, doing its modulo. And entire modulo I'm doing with 3. So I'm getting 0. So 4, 2 is 3. In that way, it is correct. But still, we have a question. You're choosing one element, taking its modulo. So now whatever I have said, you like 3 elements you will be choosing, right? So you will be having modulo as 1, 2, either 1, 2 or 3, because when you do modulo with 3, you'll be getting either 0, 1 or 2, not more than that. So this property we'll take and then we'll try to apply it. So what we're trying to do is, each element will take, okay, and take its modulo, and if that element's modulo is 0, we'll put in a 0 vector. We'll take one vector, let's say 0 vector, and we'll take one vector, and we'll take two vector. This name basically indicates its modulus is 0, its modulus is 1, its modulus is 2. Now let's say 4 will go in one vector, number 1, because 4 modulo 3 is 1, so 4 is here. 2 will go here, 3 will go here because 3 modulo 3 is 0, 1 will go again here. Okay, why we are doing this is that because now there are 27 ways possible. What do I mean by that is that, let me tell you. The element what you have chosen, right? Let's say 3 elements, any 3 elements you'll be choosing. So first element's modulo is 0, second element's modulo is 0, third element's modulo is 0, and this is a valid one because 0 plus 0 plus 0 is 0, modulo 3 do, that is also 0. First two elements modulus is 0, but third element's modulo is 1. So if you take its modulo, we have 1, and this one was 0 modulo 3, which is 0 only. This is 1 modulo 3, this is 1. So this is not our valid one because the sum has to be divisible by 3. Now you take this one, like first element's modulo is 0, second element's modulo is 0, third element's modulo is 2. So in that case, sum of these again is 2, and its value is 2. Okay, we have it's like there are 3 elements and it can change its value either 0, 1 or 2. So it has 3 choices, this has 3 choices, and this has 3 choices. 3 into 3 into 3 if you do, so it is going to be 27. So 27 choices are there. So among this, only certain choices are possible for the answer. First one we have seen. Now let's take one more. 0, 1, 0 will not be possible. 1, 1 will also not be possible. 1, 2 will be possible because its modulo, sum is 3, and 3 modulo 3 is 0. So this is also a valid one. So what I'm trying to do is, first I'll take the nums vector. I'll take modulo of each element. I'll put in respective vectors. I will take these 27 combinations. Okay, as I said, like there'll be 27 combinations. These 27 combinations can be done using 3 for loop. like you will take one for loop wherein your I will move from 0 to 2. You will take second for loop, your j will move from 0 to 2. You will take third for loop, k from 0 to again 2. You have found it. Now you have to check if I plus j plus k modulo 3 is equals to 0, which means uh, the reminders modulo whatever we have, it is 0. If that is the case, um, then what we are trying to do is, if I is let's say 0, so we will take the highest element present in the 0. Why highest element? Because we need the maximum sum, right? So in one array, whatever we have 4 and 1, when you construct this, we will have to sort this. So after sorting this 4 1 is going to be 1 and 4. So, or we can sort in decreasing way only. So it will be in 4 and 1 only. So whenever the elements we are choosing from either these vectors, we will be choosing the highest only, right? So that will make us the maximum sum. It's like basically only 27 combinations we are taking, and if first elements modulus is 0, so we are taking elements from 0. Second elements modulus is 0. Since one element, it may happen that you have, let's say, one more 6. Okay, you have 6. One more, let's say you have 9. Okay, so it will go here. So now first three elements are 0 only. We'll sort this. It will be 9, 6 and 3. So this is the first combination. So it's like first element's modulus is 0. We'll take the highest one, 9 we have taken. Second element highest is, modulus is 0. So we are taking from 0 only. Since first element we have taken, we'll have to take next greatest. At the end we'll have to take next third greatest. Okay. So this will give you the maximum sum. So I think you guys have understood how to solve this. Basically what we are doing is, we are maintaining 3 elements in 0, 1 and 2. It may happen that we don't have 3 elements in 0, we don't have 3 elements in 1 or 2. So it may happen that way also. So we'll have to make sure this. We'll choose these 27 combinations, and if at any point we don't have the elements in that combination, which means we don't have enough elements, so that combination will not be valid, so that combination will not take. So only the valid combinations will take it. So this will be the condition for that. I think you guys have understood how we'll be solving this problem. Okay. So let me try to code it up. Don't worry, I'll be explaining in the code also. Yeah, this was the code. Let me try to code it up in front of you. We'll take n as the size of the vector nums. We'll take 3 vectors 0, 1, 2. We'll take for each loop. We'll find if this present element's modulo is 0. So we'll push into this 0 vector. Else if we'll find if num modulo 3 equals to 1, we'll push into 1. This is not 0, this is 1. Else obviously since we are taking modulo 3, so it has to be 2. Okay. So we have found out these things. Now 27 combinations we'll have to see. We'll take 3 loops. So this loop will go, I value will go from 0, 1, 2, not more than 2. Okay. So once we have these elements, we'll have to check. It's like we have found the modulus I mean modulus value of these three elements. And before doing that, we'll have to, as I said, sort the vector. I'll be sorting in decreasing order. That's why R begin. We'll have to sort for 1 as well, and we'll have to sort for 2 as well. So we have sorted. Why we have sorted? Because what we're trying to do is, if let's say we want to find multiple elements from particular vector, so we will take the first highest, then next highest, then next highest. I mean first highest, second highest, third highest, that way. So here we'll have to see if I plus j plus k, which is these modulus values we are summing, and if we are doing modulo with 3, if it is equals to 0, which means modulus 3 remainder values are again modulus with 3, so we have got a valid pair. So before this we'll have to take one answer variable, or you can say max sum, which is initially 0, and here we'll have to find sum initially 0, like temporary sum. Now we'll have to check if I equals to 0, which means uh, it's like first element's modulo is 0, so we'll have to take value from the 0 vector. So if you want to take value from the 0 vector, we'll have to initialize indices as well. Okay, why indices? Because when you choose the element from first, and next time if you want to choose it, so you'll have to choose the next element, not that element only. So how do you figure out which element we'll have to choose? So for that we are taking index. So it's like 0 index zi, initially it is 0, 1 index initially 0, and 2 index initially 0. If I is equals to 0, which means the first elements it's like first element remainder is 0, so we'll have to take vector from element from 0. Now we'll have to check if this zi is less than 0 dot size, which means we don't have any element to choose. If we don't have any element to choose in the 0 vector, so that pair is triplet is not valid, so we'll have to break. If it is within the range, so we'll have to put that value. And once you're putting that value, you increase pointer to next. Okay, so if it was the case of 0, else if I equals to 1, which means we have a remainder as 1, so we'll have to choose the element from 1. Again same thing we'll have to do, 1 index less than 1 dot size. If it is within the range, then only sum plus equals to. If it is not there, then we'll have to break. That pair is not valid. Else obviously, like if I is not 0, not 1, then it is 2 only, so we'll have to choose from 2 index. 2 index less than else we'll have to break. So we have done for I, like the first element what we have chosen. So same thing we'll have to do with j as well. So now let's do with j, and here it was with I. Okay, so for j we'll have to choose this as j. Same thing again, j also, if it is 0, so from 0 0 vector will be taking. If it is 1, from 1 vector will be taking. If it is 2, from 2 vector will be taking. Now same thing we'll have to do with k. Okay, so we'll have to change here as k. So once we are at this position, which means we have found a valid triplet whose sum is divisible by 3. So now your max sum will be max sum comma this current sum, and When you're coming out of this loop, you'll have to return the maximum. Let's try to run it. Yeah, it is getting accepted. I mean, yeah, let's try to submit and see. Yeah, it got accepted, and in this way you could have easily solved the problem. And if you see the time complexity, this loop is taking off n, it is linear, and this loop is taking, it is constant, like only 27 times it is going to run, not more than that. But here space complexity is of n, because all the elements will be storing in either 0, 1 or 2 vectors, so this combined will be linear. So both space and time complexity is linear here. So I think you guys have understood. It just maybe this code is not that readable, but I think you guys have understood like whatever I've told and whatever is the logic. So yeah, thank you guys for watching the video.